Evaluate the definite integral with a lower bound of 0 and upper bound of 1 of the function r cubed divided by the square root of 4 plus r squared dr. Now, in this example, what we're going to do is we want to try to make things a little bit easier on ourselves. So we're going to let u equal r squared. Okay, and so the reason why we're doing that is we're just going to rewrite the original question going from 0 to 1. And so then what we have is r squared times r over the square root of 4 plus r squared dr. So therefore, we're going to let dv equal r over the square root of 4 plus r squared dr. Now for step 2, we're going to take the derivative with respect to r. So we have du, which is going to equal 2r dr. And then we're going to take the antiderivative of r over the square root of 4 plus r squared. Now, when we take the antiderivative of that, it's going to be a lot easier, and that's the reason why we split that up. So if we want to take the antiderivative of r over the square root of 4 plus r squared dr, we're going to let u equal 4 plus r squared. Du is going to equal 2r dr, and then 1/2 du is going to equal r dr. And so therefore, when we do our substitution, we're going to have 1 over the square root of u times 1/2 du. So we have 1/2 u to the negative 1/2 du. And then we know that the antiderivative is u to the 1/2 over 1/2, which is the same thing as 1/2 times 2 over 1 u to the 1/2. And we know that u is 4 plus r squared to the 1/2. Okay, so now that's what we're going to substitute for v. And so v is going to be the square root of 4 plus r squared. So we have the square root of 4 plus r squared. Okay, so now let's go ahead and rewrite the original function or integral. So we go from 0 to 1 of r cubed over the square root of 4 plus r squared dr. And we know the formula is u times v going from 0 to 1 minus the integral going from 0 to 1 v du. So we know that u is r squared, so we have r squared times the square root of 4 plus r squared, and that's going from 0 to 1 minus v, which is the square root of 4 plus r squared times du, which is 2r dr. Okay, so let's do a little simplification here. So again, we're going to continue to write this r squared times the square root of 4 plus r squared going from 0 to 1, and we're going to factor out the 2. So this is minus 2 going from 0 to 1 of r times the square root of 4 plus r squared dr. And now we're going to integrate this integral. So let's go ahead and do that. So we have r times the square root of 4 plus r squared dr. And so we're going to let u equal 4 plus r squared. Du is going to be 2r dr, and divide both sides by 2. So r dr is going to equal 1/2 du. And now when we write our substitution, we're going to have the square root of u times 1/2 du. Factor out the 1/2, and then we want to take the antiderivative of u to the 1/2. So we have 1/2 u to the 3/2 over 3/2, which is equal to 1/2 times 2/3 u to the 3/2. And therefore we end up getting 1/3 times u, which is 4 plus r squared to the 3/2. So this is going to be our antiderivative. So let's go ahead and put that back into our question here. So we have r squared times the square root of 4 plus r squared going from 0 to 1 minus 2 times, we got 1/3 times 4 plus r squared to the 3/2 going from 0 to 1. Now we're going to factor out the 1/3. So we have minus 2/3. And then we're going to evaluate 4 plus r squared to the 3/2 going from 0 to 1. So now let's go ahead and then simplify. So the very first one, we have 1 squared times the square root of 4 plus 1 squared minus 0 squared times the square root of 4 plus 0 squared minus 2/3 times 4 plus 1 squared to the 3/2 minus 4 plus 0 squared to the 3/2. Okay, so here we have 1 squared, which is 1, times 4 plus 1 squared, which is going to give us 5. So we have the square root of 5. And this is 0 times that, which is 0, minus 2/3. Okay, so we have 4 plus 1 squared. So that's going to give us 4 plus 1 squared. And that's going to be raised to the 3/2. Minus 4 plus 0 is going to be 4 raised to the 3/2. So over here we have the square root of 5 minus 2/3 times the square root of 5 to the 3rd power minus the square root of 4 to the 3rd power So we have the square root of 5 minus 2/3, and this is the square root of 5 squared times the square root of 5 minus 2 to the 3rd power. So we have the square root of 5 minus 2/3 times 5 times the square root of 5 minus 8. And now let's go ahead and distribute the negative 2/3. So we have the square root of 5 minus 2 times 5, which is 10/3, times the square root of 5, plus 2 times, or minus times the negative is positive. 2 times 8 is 16/3. And then if we wanted to combine like terms, we would turn this into 1, which is 3/3. So we end up getting 16/3. And then combining this gives you minus 7 over 3 times the square root of 5. And there is our result.